Welcome back, everyone. Today we're going to talk about computer design and just how cool this and fun this stuff can really be. Now, I'm just getting my toes wet with computer design software. Because of where I work, I actually have access to the full suite of Autodesk software, which to the masses is considerably expensive, or if I decide to use it for commercial purposes. So I decided that, I kind of wanted to learn how to do this a long time ago. Now I'm at a point where I really could use this software to do some pretty cool stuff, and I decided to just go in head first and just see what I can do. So I followed an online tutorial for Autodesk Fusion 360 that helps you, it walks you through the steps of creating a tangible object. In this case, that object is a stamp. And this piece here comes in two parts, the handle and the removable stamp piece. And every aspect of this I drew just by following instructions. The only thing I did differently, I actually customized it a little bit. I put a chamfer around the top of the stamp body here. That was not in the tutorial, but I was just kind of fooling around and I did that on my own. But anywho, this stamp is actually upside down. It's supposed to be the other way around. Whoops, I must have screwed up somehow. Anyway, so Autodesk Fusion is a piece of software that you can acquire. It is expensive. It is very expensive. It's actually, Autodesk has always had funny license models where you have to keep paying them. Back in the old days, you would you would actually receive Autodesk software in giant boxes of like 400 floppy disks per box, and what you would do is you would have to insert a parallel port widget that would identify. It's actually for copy protection. They've always been very protective of their software, and rightfully so. But anyway, because I have this, basically the full suite of software, I was able to take this drawing here that I made this about 2 years ago in Punch. And Punch it's a consumer class design software that helps people design custom editions on their homes. You can landscape your house on the computer, take a look at it, make changes. In my case, I took the entire house, the entire building, and I recreated it accurate to the nearest probably 3 inches or so. The entire home's layout is right here. All measurements, doors, windows, walls, and I even did the basement. Now let me show you that. The basement in this particular file isn't here. Let me open the right one. That'd be this one right here. So this one has a proposed finished basement. This is where I'm sitting right now. For reference, I'm right here. And I can change the floor. I can look at how this affects the floor below and vice versa. All I've got to do is select the top floor, and there I am. And you can see in light blue the lines that are below it. So you can see how things kind of correlate. So that's kind of what I've done. And the garage, breezeway, etc. And what's even cooler about this is I can do a 3D view of the whole building. It even shows you above ground and below. But this wasn't too hard to do. This was pretty simple. I also did some proposed changes. Like, for example, if you look at the breezeway in this drawing here, let me just kind of fly around here. If you look at the breezeway and garage, there are 3 windows right here, 3 double hung windows. And right now, that's where 3 sets of jalousie windows currently exist. And then there's a door here, and then there's the garage door. So, but that's accurate, very accurate. If anything were to happen to this house, I could use these drawings and send them into a builder, and they could rebuild the whole house exactly the way it was. And let me show you what's even cooler. Punch, which is like a $59 piece of software, it's very inexpensive and very simple. I can export this file as a DWG file, which is readable by Autodesk's AutoCAD suite. I can then pull up AutoCAD, and there it is. So this is a file that I could send to a legitimate builder and say, hey, my house burned to the ground, I want it rebuilt. Here are the drawings I have, and I can give them the actual CAD files that they can use to then add in proposed HVAC, plumbing, electrical, you name it. And they can also make changes to make it code compliant and then submit the plans over to the city or the town. Pretty cool, huh? Now, Autodesk AutoCAD is, I think it's like a couple grand per year per user. It's one of the most expensive pieces of software that I support on a regular basis, besides maybe our accounting software. This stuff is very costly. The nice thing about Autodesk is that they do provide educational licenses for free. So I was able to acquire licenses for my company, my organization that I work for, and in turn I support the entire design lab and whatever needs they may have. And because of that, I have to know how to use this stuff. Okay. Anyway, so this is the entire house, as you can, as imported from the Punch. So that's pretty cool. Now, in the process of learning how to use this software, which is intense, the learning curve is massive. It is hard to do. It's not easy. Not for me. I was able to acquire a license for Autodesk Fusion, and I was able to follow an online tutorial. It's actually a YouTube video, and I'll share that with you guys in the. I'm going to put a link to the YouTuber in the comments box. I'm sorry, in the video description. And this is the item that I designed. It's a stamp. I think we just talked about this earlier, or maybe in another take. I've taken this video 4 times now, so I don't know if I talked about this. But this is a hand stamp. It's a very simple it's 2-component drawing. You've got the handle and you've got the stamp that's removable. And because we're in 2022 now, heading into 2022, desktop 3D printing is ubiquitous. And I was able to make this from this drawing. Oops. So this is the fruit of my labor. This is an actual hand stamp with a removable stamp plate. So that particular tutorial has you design these chamfered edges, although the term is something else, bevel maybe. It warped a little bit on the 3D printer bed, but you know, that's what you get. But otherwise, I mean, I printed this at fairly low quality without any supports. So it came out okay. Now, let's talk about 3D printing for a moment. This is my very first 3D printer. I just acquired it. This I got from somebody who bought into the DaVinci 3D printer space and realized very quickly that it is a losing game. DaVinci, they wanted to make 3D printing accessible to the masses by pricing their machines and their supplies almost in the same model that HP, Lexmark, Epson, Canon, Brother, etc., in the same model that they use for their printers and ink. That is, they sell the machine at very close to cost with a very low profit margin, but they charge a fortune for the supplies. I want to talk about that specifically. When this printer was new in 2014, now this is a dual function machine. This is a scanner and a printer. And later in this video, this is a long video, so please be patient. Later in the video, I'm going to go over 2 things. I'm going to show you how the scanner works or doesn't, And I'm also going to show you how to calibrate the machine. So if you're really, those are the two things you want to do, just skip ahead. That's how you're going to find it. But we're going to talk about calibration. We're going to talk about, well, I might show some sample prints. Well, this is one of them. And I'm going to tell you how to calibrate your machine if it will not calibrate, which was the case on this one in particular. In 2014, this printer sold new for around $800. In 2014, that was a bargain. In 2014, $800 was ridiculously cheap, because 3D printers were still priced above $1,000, well above $1,000. The supplies were never terribly expensive on 3D printers. Even today, you can buy a roll of PLA or ABS plastic filament for around, it's 1,000 grams. Hatchbox sells 1,000 grams for about $20 or so. Not bad. $20 for 1,000 grams of filament. That's pretty reasonable, right? Well, DaVinci, like I said, they lower the price of their machine. They pack it with features. They make it as user-friendly as they can. Now, the features that this machine has that were considered premium back then is it's a fully enclosed machine. A fully enclosed 3D printer will often produce better prints because the printed object is not susceptible to breezes or wind blowing past it and causing it to cool too quickly. So it's kind of a self-contained ecosystem, if you will. Not really, but generally you get better results with a fully enclosed machine. It is a lighted machine. It has a work light to show you what's going on in there. And it times out after about 3 minutes, and then you just press a button and it lights it back up again. It has a fully heated bed plate made of glass. Now, this particular bed plate is about 7.8 by 7.8 inches square by, I believe, 7.5 inches tall. Fairly sizable for an entry-level 3D printer. At the time, that was pretty damn good. It uses PLA, ABS, or flexible filament. All of them have to be acquired from DaVinci. Let's talk about that for a second. So the filament is housed on these earlier machines, these earlier DaVincis. It's housed in a removable cassette that can be opened, and the filament rolls can be changed in the cassette. But the cassette model, it's actually quite handy because it's a drop-in load, and then you just pull the filament out and then feed it through the hose into the print head. But the devil is in the electronics that cassette holds. There's a small EEPROM chip that the printer is designed to read and write to. And what it's doing is it's saying, okay, you put in a new cassette with new filament in it. The printer will know what color you're using, what material, ABS or PLA. And that, by the way, is how the temperatures are set for the bed plate and the nozzle. So those are not user adjustable settings on this machine. Like I said, DaVinci was trying to come out with an entry-level, easy-to-use, almost like an easy bake oven 3D printer for the masses, for the non-engineers, for the hobbyists, not for major corporations trying to prototype real parts. And in doing that, they did simplify the process, or dumbify it, idiot-proof it, if you will. Dumbify, that should be a word. By not allowing you to adjust the temperature settings. Okay? Not only that, but they also designed it so that you can only use DaVinci's own software, which kind of sucks. Anyone who's used a DaVinci machine, and I've used several, because we have a bunch of these at work. The DaVinci Juniors are very popular where I work because they are easy to use and they're idiot-proof. But the software is where things really start to get pretty shitty. There's not a lot of customization. It's just, I believe the software of choice that we use on some of our other 3D printers is Cura. So in order to 3D print an STL file, you need a slicing program, and that's what XYZware is. It is free, but you can't just download it. You have to have an account with DaVinci, which is free, but you still it's still tied to the mothership in a way. But this is what XYZware looks like. This is your slicing software, and this is how you print or send a job to the printer. And it will work with any STL file. For example, here's the handle I just printed. That's this guy. And, you know, it works with any STL file. I can rotate it. I can put multiple parts in the same build plate. I can add, let's see, we'll put the plate there. I'm going to add some, let's see, what else can we add in there? So you can actually, in order to save yourself some time, we'll put a cat in there, because why not? So there's a cat, we got a handle, we got, now you notice that it's all in black. Well, that's because it knows I have black filament loaded. Pretty cool, huh? Well, that's what that chip does. That chip identifies the color, the material type, but it also records the amount of material used. So we're unloading the filament now. I'm going to show you what the cartridge looks like. There it goes. Sweet. Okay, so we've unloaded the filament. Now let's pull the cassette out, and I'll show you what that looks like. I've got to take this little clip off. Now this is where things get pretty shitty. So what if I wanted to refill this cassette with new filament from Hatchbox or from any other major manufacturer? All I got to do is remove this lock, and I think I have to cut this label here. Let's see. I have a knife here somewhere. There's a razor blade. We've got to cut this label right here. And pretty much just gingerly, gently peel it apart. It should be pretty easy to do, right? I think there's a clip here somewhere. Yeah, right there. There we go. And that is how we disassemble it, correct? Look at that. And this is a spool of, this is actually genuine XYZ black with a silica cartridge thing in there. Pretty neat. And that's it, right? Just put in a new spool and go. This is where things get ugly. So, like as I said, it knows what material, but it knows how much is in the roll. So it starts off with a new roll. You'll have whatever the length is in a 600 gram roll of filament. It knows that there's, let's just say there's 200 feet of filament on the roll. Okay, there's 260 feet of filament on the roll. Every foot that's taken off the roll, it records it and it writes it back to this little chip here. And the chip knows, oh, wait a minute, you just printed something that wasted used 100 feet of filament, which means there's now 200 or 150 feet back on the roll. And when it runs out, it tells you, it either won't let you print the job, because when you send a print job from XYZware to the printer, it knows it's going to need 160 feet of filament or whatever. And it's going to know that, wait a minute, your supplies, your black roll of ABS does not have enough to print this job. So, sorry, kid, print denied. Well, that's kind of smart, because if you're 75% of the way printing a particular, let's say I'm all the way up to here printing this handle, and there's not enough filament, it's just going to keep going and going and going until, if there's a switch that shuts off the printer when the thing runs out, it's going to stop. But I can't continue on. I can't restart it and continue. I have to start all over again. So on one hand, it prevents that level of waste. But on the other hand, and this is where things get really nasty, even if I have a way to reset this, which I do, it's been cracked already, firmware updates have figured out a way. They've decided that, well, wait a minute. People are learning how to reset these chips and reload these spools. We need to stop that because we're losing money now. We sold this printer for $800 because we would expect it to make it up in the back end. But if people are continuously using refilled spools by resetting our chips, we have a problem. So, what did the manufacturer do? They issued a firmware update, which this machine now has, that prevents you from using, because it can detect when these are reset somehow. You reset it, by the way, with a modified Arduino and some software. It's all available, but now it's useless. But you can reset this chip. We can't have that. So what they did is the first thing they did was they issued a firmware update that prevents you from using a reset filament ID chip. Secondly, after that was cracked, and it was, they got smarter. They said, well, wait a minute. Why don't we have the software communicate back to the printer so the software knows what was used on that spool? So the software is now keeping track in addition to the printer, so it's a big mess. You can't reset them anymore, as far as I know. So you are locked into buying supplies from XYZ unless another hack comes out. But I think by now, this printer is now 7 years old, there's not much of a market for that. So the end result is this. This printer, which only had 10 hours on it, was essentially discarded because the person who owned it didn't want to pay for materials. They didn't want to pay extra money. How much extra, you might be wondering? Okay, this is a 600 gram spool. Okay, 600 grams. Typically, a 1,000 gram spool of ABS or PLA. ABS is a toxic option. PLA is more environmentally and health friendly because ABS, by the way, puts off carcinogenic fumes when you print with it. But it's a stronger print, I think. PLA, on the other hand, is a little more eco-friendly. But anyway, same price regardless of material you use. 1,000 grams, like I said, of Hatchbox, which is a very popular filament brand. That's about $20. 600 grams of that's 600 grams. That's just over half of the amount you get from the competitors. 600 grams is going to run you $25. They may not seem too bad in theory, but there's a few caveats. The only reseller that I could find that isn't Amazon, by the way, I still don't have an Amazon account, and I never will. B&H Photo sells XYZ stuff, but you can buy it from XYZ directly. The catch is to ship one roll of filament, which costs $25. They charge you, I want to say it was $10 or more to ship that roll. So let's do some ordering on their website. I'm going to show you just how costly this shit is. All right, so here's a couple of things you want to know. DaVinci or XYZ Printing does sell supplies for this model. They sell them as refillable or refill rolls. So they'll sell you these cassettes. These cassettes are $10 a piece. I bought a bunch of these, and the rolls are $25 a piece. So let's make a fictional order. Fictional. So these are the colors you can get. They got white or nature. They do have white. Here's white. Nature is uncolored. Blue, red. They also have some transparent ones. Although I'm not seeing them here. Yeah, 600 grams. So they don't have any transparent ABSs actually. So let's buy a roll of black. $25. Doesn't seem too bad. 600 grams. What the hell, right? Buy. Oh, they do have a 1 kilogram filament, don't they? Oh, I did not know that. Let's see what that looks like. Buy 1 kilogram. $22.95. Really? I didn't know that. Oh, wait. DaVinci 1.0 Pro and 1.0 3-in-1. So that does not work with our machine. Only the 600 gram rolls will work with our machine. But anyway, it says it works with our machine. Now, did I mention not only does their software suck, but their website is kind of scattergories. It's all over the place, and it's very confusing, more so than it should be. But all right, let's just see what our $25 roll of filament is going to really cost us. So watch this. I'm going to open up my grocery cart here. Here we go. Let's check out. So yeah, without shipping, it's 25 bucks. Not a bad deal, right? Right? Wait till I put in my info. Look at that. $61. $61 is my subtotal. Now, if I select ground residential, $45. Yeah, $45. Now, you might be thinking, okay, what if I get a bunch of rolls and I only have to pay the $20 shipping? Well, that's where you'd be wrong, my friends. $42. They want to charge $42 to ship 4 rolls of filament. Whoa. Now, it's starting to look like HP's business model is a little more reasonable, doesn't it? It's $141 for 4 rolls of black filament, 600 grams each. Yikes! How crazy is that, my friends? That is insanity. I don't know how they get it. I don't know how they sleep at night, or how anybody buys these machines new. It is such an effing ripoff when you really do the math. Here's the good news. You can buy the stuff from B&H Photo. Now, not only do you get the spool, you also get the chip. So you don't have to worry about the chip anymore. It comes with a new chip. You don't have to worry about it. $24.95. Let's say I want 4 of those. Add to cart. And my shipping is free. So I get it for 99 bucks. And that's how I'm going to buy my supplies. I'm going to buy them from B&H Photo, and I'm going to use this machine. I'm going to learn how to 3D print, and I'm going to do all the things I can do with this machine. I'm going to buy the supplies from B&H Photo and not get hammered by shipping costs. Because if you're buying the stuff directly from DaVinci, you are going to get screwed. It's sick. It is sickening. They could be making money off of me, but they decide not to. So, if you have one of these machines, save these cassettes because they're very handy. You can have every color you have can have its own cassette, and you don't have to keep changing them out. Makes perfect sense. They charge $10 a piece for these, and here's the sad thing: I can't get these cassettes anywhere else. I can only get them from DaVinci. So I did end up bucking up for a couple of these cassettes, and I also bought 1 roll of filament from DaVinci directly. And I forgot to put the filament through it. But this is, that's how they do it. And they're making money, I guess, somehow. Now, the next part of this video is going to be super long, and we're going to talk about calibration. And I'm going to show you another print. I think I may have cut that out, but I may or may not show you guys another printout that I did with this thing. A couple of tips and tricks before we dive in. When you're loading your filament, if you're using a cartridge that you've already used, make sure to give it a nice sharp cut with a pair of clean and sharp side cutters. You want to give it a nice 45-degree angle cut. Now, I support a lot of DaVinci machines at work. When they break down, which is pretty rare, I step in. When the users screw them up and jam up the heads, I have to clean them out. I've done a few minor repairs to these, and The one thing I can tell all of you guys is no matter what you have for a 3D printer, make sure you give that filament a nice 45-degree or more cut so that it feeds cleaner into the head. So we're going to drop this cartridge inside. A couple of things I want to also mention. The earlier DaVinci machines, like this one here, they use a contact type EEPROM chip. If the cartridge fails to detect it first, try cleaning those contacts with alcohol. If you have a machine, a newer one, like for example a DaVinci Junior, they use a proxy chip. So they don't have it's actually mounted inside the hub and does not make direct contact. It works just like an ID card for, you know, opening up a door. So this gets fed down in here into the head. These earlier machines did not have a straw that goes from one point to the other. They just used that little nublet there. We're going to do change cart, load filament. It's going to bring the extruder up to temperature, and it's going to start drawing it in. So we're going to leave this open for now. And then once we finish loading up, let's get this stuff out of here. I'm going to show you a couple of things. We're going to level or calibrate the bed plate, and we're going to clean the extruder nozzle. Hope that's entertaining for you guys. So let's get this loaded in. Let's take a look at the menu here. So in the utilities, you have, of course, your cartridge change, which heats up the nozzle and reverses the feed to eject whatever material might be in there. Okay. And you've got, of course, every 3D printer has that feature. Home axis, which will home the build plate. And it raises it up. While we're here, let's make sure that build plate is good and clean. A little bit of residue on there. Clean that off. Clean it with rubbing alcohol. Of course, I should have cleaned it before I homed it. That's alright. Do shit like that. Let that dry out. Now, if you go to jog mode, it will allow you to raise and lower the plate in up to 0.10 millimeter or 10 millimeter increments. And then you've got your calibrate, which we'll look at in a minute. There's a couple of sample demo, line, or lighthouse. Those are for if you know, once you initially unpack the machine, you just run those. Every printer pretty much does that these days. It's nothing fancy. Clean nozzle. That's going to heat up the nozzle, and it will feed filament through it. If it's ever clogged, that's how you get that cleaned out. Settings. You have very few settings on this machine. Buzzer on or off. Auto heat on or off. Language. Energy save feature. We're going to raise that to 6 minutes. And then I'm going to go back home. Info. This is where you find out the printer's lifetime status. So lifetime has now been 30 hours of power on time. Last print time was 20 hours, rounded to the nearest hour. 124, that's our firmware version, system version 124. Cartridge status, 109 meters remaining, and capacity is 240. So we used about 100 meters, give or take, when we printed that Tiki. Color black, material ABS. And then there's help, just how to get to the website. So, settings, utilities. I'm going to try another calibration and see what it does. And we'll see how that goes. Now what it's going to do during calibration is it's first going to reach operating temperature, so we have to wait forever. So this is typically what you're going to get. So it's measuring 3 points, the far corner, this corner, and this corner. Each of these numbers represents the reading on each corner. And if they're not within a range, a certain range that only is known to DaVinci, it'll fail. Now, what it's going to do is it's going to fail and give you a numerical value for each position. If it fails to get a numerical value, you get error, 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 or numerical, error, numerical, whatever. So, what are we going to do about this? So, we're going to drop the bed plate down. Where am I going? Settings? No, utilities. We're going to jog the bed plate down. Oh, let's try 10 millimeter. I'm going to just get it within reach. So what am I saying? Is this printer a colossal piece of junk? Absolutely. Like I said, I wouldn't pay money for one of these, but whatever. I bought the supplies because, well, what the hell. Now, I've already cleaned those contact pads with emery cloth. Basically very fine sandpaper. And I did a damn good job of it, if I don't say so myself. Now, it never measures the far left corner. Only the far right and the two fronts. We're also going to jog the head assembly. X, Y, I think we want to do Y-axis in 20 millimeter increments. Wait. There we go. We'll bring the whole shoot and match over to us. Okay. We'll remove any excess material from the previous print. And we're going to go ahead and we're going to clean this little probe here. Let me put the light on so you can see what the fuck I'm doing. There we go. This little probe, it looks like it might have gotten some buildup. Okay. So, actually the whole head has some buildup on it. Well, that would be the problem right there. So, here's what we're going to do. I'm going to heat that sucker right up. All right. Let's see. Clean nozzle. Yes. So what that's going to do, we're going to clean all that burnt crap off the nozzle with the included, this came with the printer, this brass brush. Oh, it's bringing my bed plate. That's okay, I've already cleaned the corners. Okay, now it's going to be heating the extruder and not the bed plate. So the bed plate will remain room temperature. The extruder will reach operating temperature. Once it does, we're going to jog the head over to us and we're going to clean everything with this little wire brush. You just missed it, but it uses this little rubber thing to wipe the nozzle clean between prints. It just did that for me, and it doesn't really do much. So it looks like it's bringing it over to me. Ready for clean. So you see how that brush, now it's nice and hot, so our brush is able to cleanly remove all ABS residue. Residue in French. So we're gonna just do our damnedest to clean this sumbitch. Just like that. Look at that. Look at how clean that is. There we go. Look at that. Now, it's interesting that we have these sharp wire bristles so close to electrical wiring, which kind of makes me a wee bit nervous, but brush your teeth, Johnny. And all that crap is going to get all over our freshly cleaned bed plate, but that's okay. Look at that. Nice and pretty. There we go. Now, on the other models, the head is removable. Not so much on this one. It can be removed. It's just not as easy. But I think that's almost good enough. There we are. Look at that. Huh? What do you think of that? Too much. Too much. Look at that. Clean as a whistle. Alright, now we're done with that. We're going to run our calibration tool again. Okay. So we'll let it do its thing. It's going to heat up and then it's going to go boink, boink, boink. Okay, ready for another calibration fail? I am. Here we go. That is the most overworked stepper motor I've ever seen. Well, let's look at the way they built this build platform. The whole thing is made of plastic, balanced on a piece of plastic. It's kind of, I mean, the thing is, plastic is not dimensionally stable. So it's going to go in and out of calibration constantly, right? Okay, so we know that the upper limit sensor is working. That's that little optical sensor right there. So it's going to bring it down to where it thinks it needs to be. Here comes Mr. Head. And it should just tap and go. Yep, just like that. Tap and go. Tap and go. Tappa, tappa, tappa. Alright, so that was a success. Now let's try this one. Tap and go. Yep, as soon as that contact is closed, it says, alright, it's my thumb by the way, move on to the next one. Alright, here we go, tappa, tappa, tappa. And good. Got 3 points of contact. Now is where it's going to go home and report its findings on screen, and we're going to see whether it passed or failed. I can guarantee you it probably failed on all 4 counts. Here we go. So what it's doing is it's measuring from one set point to the limit, the distance from each corner to the set point. So it failed. It's 257, 216, and 181. Now, I think the first one is the first reading, and the second one is the second reading. So we have to do a manual calibration of this printer. And to do that, to get it closer into range, we're going to go back into Utilities. We're going to do a demo print, build sample. Lion, yes. Now here's what we're going to do. We need to get the printer we need to do a couple of mental gymnastics to get the bed plate within range. there are 3 adjustment points. And once this thing reaches temperature, it'll start printing. As soon as it starts printing, we're going to cut its life out. We're going to stop the print. That made no sense. Cut its life out. So as soon as it begins to print, we're going to halt it. We're then going to take a sheet of paper. I tried it with feeler gauges and it didn't work out. So we're going to use a sheet of paper and we're going to get each of the 3 touch points to contact just enough. Then we're going to rerun the calibration. Okay, it's going to clean the head off with that little flappy flap. Just like that. Boom, 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 boom. And it's going to start printing. Here we go. All right. All right, so it's laying down some tracks. And we kill it. There we go. Now that we've done that, we can freely move our head to do with it whatever we please. Pull it over here, and I'm going to get myself a piece of paper. This is where it gets interesting. So I'm going to use a 0.4 millimeter feeler gauge. I'm going to clean off the filament from the head there. And you want to just run this 0.4 millimeter feeler gauge and adjust the bed plate adjuster until the feeler gauge just starts to grab. Just starts to grab. A little bit at a time. Patience is a virtue. You can use paper, that's what everybody seems to be using these days, but I like to be weird. Why won't the light just stay the fuck on? There we go. Alright. Okay, that's fine. Now this is where things get interesting because they decided to put 3 points of adjustment rather than 4, and the bed plate is going to be inevitably warped a certain degree. You have to kind of play a balancing act. See, this one's too tight. Okay? Too tight. Too much. So I'm going to adjust this one. I'm going to turn it clockwise to lower. The clockwise on the thumb wheels lowers it. Counterclockwise raises it. So we have just lowered the bed plate just a wee bit. I think that'll be fine over there. But now we have to double check our work. Good in the back, good in the front, but is it good on the far left corner? I think it's passable. Because remember, when you lower that point, it raises this point. You're never going to get all 4 corners in balance, just so you know. That's a bit, okay, it's a little tighter than this one here. So what I could do, how is the front look? Because we might be able to, I think that's good. I really do. I think that'll do just fine. So why don't we power back up again? There we go. And we're going to run the calibration one more time. All right, that worked. So you'll see 241. So that's measuring in, I believe, that's pretty damn close. I don't know what that, well, all right, 0.40 millimeters. Of course, that's an arbitrary measurement. But I believe that is 0.24, 0.23, and 0.23. So it's within spec on all 3 corners. And that's how you do it. You take a known measurement. I would do, apparently 0.4 millimeters works, and use that as your calibration set point. Unfortunately, the way this bed plate is designed, that far corner over there will not meet that spec because it is warped for certain. It's just kind of a... But then again, it's not measuring that far corner either. So that's kind of interesting to me. Anyway, hope this was a great video. Why don't we do some 3D scanning next? So for my next trick, I'm going to show you what this printer really sucks at. By the way, the calibration should only need to be done, you know, if your print quality is starting to get inconsistent or you have adhesion problems, especially when you have adhesion problems. Then you might want to look at your calibration. But what I want to do next is I'm going to show you just how bad this thing is at scanning. So here I have an object that I'd like to scan. I have owned this piggy bank since I was born, as a matter of fact. I'm going to place it right there. Now this is a little bit too large, I think, because as you see in a minute, it doesn't scan all of it. So I'll show you what I mean. The software is where, so XYZ software is buggy, and there's so many typos in the dialog boxes, in the menus. Everything is just, it's really kind of has a built on a Friday evening vibe, you know, just before the bars open, I guess. just as work gets out. Hey, by the way, I know that you're going home in about 30 minutes, but I need you to quickly whip up some scanning software for our new 3D printer. Can you do that? Thanks. Thanks, Peter. Anyway, so I'm going to do a quick scan here. We'll do normal, select mode normal. I've tried auto. It doesn't seem to matter, but I'm going to hit OK. Now, there are some advertisements for this machine that show crisp scans, no issues, everything's fine, everything's beautiful. That's a fantasy. I'm going to show you reality. Again, this is a product that has been out of production for a number of years, so it's kind of a moot point at this point. So we're going to do a scan here. It even shows you. Here's how to put it on. We'll hit scan. Watch this. Okay. You'll notice that there's some shadows here and there. That's going to throw it off. By the way, you don't want any direct light going into it. That's key. Although the light behind me should be fine. Now it's going to show you on screen. It's going to show you a little bit of what it's captured. You can see that's starting to fill up. Watch it make a liar out of me. Now you'll notice that it's not getting the top of the head. That's okay. This object is too tall. I forget what the maximum dimensions are, but this is too tall for it, for sure. Okay, we got the basic outline here. So it's going to scan with one laser, and then it's going to scan with the other. I've already calibrated the machine. If you get one of these that's missing this right here, it's pretty much a useless machine. I mean, more useless than it is normally, because you need this to calibrate the scanner, which should be done, from what I can tell, on a regular basis. Anytime you move a machine like this from one room to the next, or if it gets jostled or what have you, then it might be a good idea to do a calibration on both the bed and the scanner. So just keep that in mind. I mean, it really tries, it tries, but you know, it's just not quite there. It should go back in the oven for about another hour or so, and then it'll be done and ready to be used. So let's see how our object is looking here. So I think we're looking at, you can see where it, yeah, that's the feet. Okay, so it's scanning the shoes now. All right, Then it's going to switch to scanner number 2, which is from a different angle, shooting down. This laser shoots up at an angle, the other laser shoots down. And it blends the two images, which is why calibration is so critical, to create a solid 3D object. So we're halfway through. Next, it's going to fire up scanner number 2, which punches down. And we're going to see what it captures. And that's, so you'll notice from one angle it might show a shadow, but from the other angle it captures what's supposed to be in the shadows. Do you see what I'm saying? You picture, I mean, you're picking up what I'm putting down? But yeah, there is a hard cutoff limit on the head. As far as I know, I can't see the top of this image, but yeah, it's going to cut off like the very top of this head. Let's see how Mr. Piggy Bank came out. Alright, so here's our image. We're going to zoom in. He looks almost demonic. Now, it may look startling at first, but there are some built-in mechanisms for smoothing out the images. So you see the outer limits of his feet were missed. But overall, it's a cohesive image, and it seems to be pretty well in calibration. It's just, it didn't get all the details that I wanted it to, but it actually didn't do too bad. Now, multi-part scanning, or multi-scanning, is, let's say it missed the ends of the feet. You can scan it again. You can reposition it on the bed and have it, give it another chance to recapture what it missed, and then you have to blend the two images together. I tried that, but it did not work for me. So we're going to just not do that. If there's anything in the image that is unwanted, you can cut it out with this eraser tool, but we're not going to do that. We're going to just kind of let it fly and see what happens. Now it's going to render the image, and we're going to give it a few minutes to do that. Okay, now we get into the finalization of 3D scanning, the smoothing. Okay. This is the image that it wants to produce. This abomination. Now you saw what it looked like before. Didn't look this bad. I'm pretty sure it had a face. That, my friends, that is a software problem. This software fucking sucks. Now watch this. This is it. This is our bastard of a creation. You know what it's saying right now? It's saying, kill me right now. It is saying, please kill me. Put me out to death. Put me out to pasture. Really? Because it had a solid image. Now it doesn't. That's my point. We can't print this. We can't do anything with this. It's useless. It is an abomination. And that was entirely due to software issues. Now, we've calibrated the son of a bitch. We're going to have to calibrate it again. What the hell? Why don't we calibrate it again? Then we'll try it again. The same object. Right? So, we put our calibration jig on the wheel, and we hit calibrate now. I do not want to participate in the user experience. Thank you very much. Calibrate now. Enable tooltips. Close the gate. Okay. We'll let it calibrate because we got time. Eventually it'll start. I gotta take this camera apart and figure out what the hell that noise is. Anyway. Okay, Hot Pockets are ready. Ooh, that's hot. Just kidding, it's not really hot. Scan our next object. Let's try this one more friggin' time. One more time. That's all I'm going to give it. I mean, this is the most useless 3D scanner ever produced. I promise you. Alright. Let's try again. Lasers on. Did I miss something? It's not turning. There it goes. That's just a class 1 laser, by the way. It's not going to hurt anything. But it's pretty obvious to me why this machine was so short-lived. It was a terrible product. Great idea in concept, but otherwise not a very good execution. Now, to improve our results, I'm going to shut this overhead light off. We'll see if that helps. This one too. We'll have it scan in complete total darkness. I think it's worth a try. You know, I like this camera so much, I might just buy a used one on eBay. I really do. These Sony or these Panasonic cameras are actually decent products. This camera has served me well. I think I bought it in 2018. About 3 or 4 years old now. No, I bought it earlier than that. I think I bought it in like 2017 or 2016. Damn. Yeah, it's really given me some pretty good service. But it's been dropped so many times that I think its days are numbered. Okay. Now this takes a minute. Now look at, let's say, I mean this is pretty bad. Okay. It's never going to get those these deep crevices because they're out of the reach of the scanner, and there's nothing I can do about that. Telling you though, this software though, it is so poorly written and just so bad. Unhandled exception. Oh great, what now? I can't see. It's just, look at that. It just. Let's try another object. Make sure to put this thing back. You'll notice that there's actually room for another cartridge. This chassis was used for a couple of different models. It was used for the all-in-one, which has the world's most useless scanner, and we'll talk about that too. There we go, it's loading. You can feel it grabbing. There it goes. You know, when you really think about it, a 3D printer is really just a computer-controlled glue gun. It really is. That's all it is. It's just a very fancy computer-controlled glue gun. Uses the same technology, really. Anyway. So yeah, we're gonna do a couple of things. We're gonna fix up that bed plate. Oh yeah. So what I was gonna tell you, they use this for a dual color, dual nozzle version, which is the one I wish I had, but this one was free and I'm not going to complain. Now I'm going to show you, when you load your filament, you want to make sure that that filament comes out nice and straight. You don't want it curling around, you want it coming out straight. Just like that. Otherwise, you could have a blockage in there somewhere. And when that stops, we're going to just trim it off. There we go. Yep, that looks pretty good to me. And that's how thick it comes out. And you can measure this with a pair of calipers and see what the dimensions are. That's how you know what size nozzle you have, if you don't know any other way. Thank you all for watching. Let's move on to the next phase of this video. By the way, I fixed my camera. Well, kinda, sorta. In parts of that video, the camera makes some pretty gnarly sounds. I figured out that it's the optical image stabilization motor that's acting up, so I just disabled it. Don't really need it.